Today is a really special day for me. It's my first time at Indaba. It's also my first time in Africa. And not only that, so this month is also my research anniversary. So my journey as a researcher started pretty much exactly 20 years ago. And back then I was a PhD student attending my very first conference, like maybe some of you today. And back then I presented a pretty wild idea, using human feedback to guide reinforcement learning. And I was told, very politely, that this would never work. Well, it turns out I just had to wait 20 years. Oh, sorry about that. I just had to wait for 20 years, and now we have a very similar framework, but under a new headline, namely AI alignment. So today I want to talk to you about the future of AI alignment and how we can ensure that we build truly beneficial AI for everyone. So when I was preparing this talk, I was reflecting, why are we all here? Why are we doing all this work? And I believe it comes down to a shared belief in the promise of AI. For example, we see the promise in its potential to accelerate human knowledge, improve our collective future by tackling huge problems like climate change and globalization, and just as importantly, we see the promise in empowering every individual, irrespective of their background. So I was saying there's a lot of promise in AI, and I know that a lot of the brilliant work being presented here at Deep Learning Indaba is pushing forward on every one of these promises. And in fact, later today, we'll hear more about the promise of AI by the next keynote by Max Welling. But like any powerful tool, AI also has risks. And let me illustrate one of the biggest challenges with a quick riddle. And please note that this is purely hypothetical. So here it goes. A father and his son are in a car accident. The father tragically dies at the scene. The boy is rushed to the hospital for emergency surgery. But the surgeon looks at the boy and says, "I can't operate. He's my son." So how can this be possible? Can you figure it out? We have a guest from the audience. So this gentleman is totally on spot. So of course, the surgeon is the boy's mother. And the first time I heard this, it took me a moment to figure it out. And that little hesitation that many of us experience, that's what we call unconscious bias. And it's just a natural part of human being. And so it's not surprised that when we train AI on vast amounts of our data, it learns our biases too. Now, the problem of AI bias and other related harms isn't exactly new. Some of you may remember Microsoft's Taybot or the famous Compass study, which we've been discussing now for almost a decade. But what's dramatically different right now is the sheer scale of AI, which is driven by two things. First, increased capabilities, but also massive user adoption. And this is where the stakes become incredibly high. So AI is no longer a tool just for us experts like it was just a couple of years ago, but it's now literally used by everyone, and that includes vulnerable groups. So for example, the Turing Institute has found that already 1 in 4 children in the UK are regularly using generative AI. And for us, the people who built this technology, this creates a profound tension. On the one hand, there is our duty of care, and on the other hand, the drive to create powerful and useful tools. And this fundamental dilemma is what AI alignment must solve. So today I will tackle this fundamental tension heads on, and I believe the solution requires 3 fundamental shifts in how we think about alignment. And this is really the key message of my talk, which I will elaborate on in the next 45 minutes. So first, alignment is intentional. I will argue that we need to deliberately choose who we are aligning to and what goals we are aligning for. And second, alignment is plural. I'll show you why the hunt for a single ground truth is a trap and how we can embrace a world of diverse values. And third, alignment is deep. We're going to look past the shallow metrics we're using today and ask, how can we align our models for genuine long-term well-being? And to see why these shifts are so important, let's quickly get on the same page on how alignment typically works. So here's a 1-minute version. I assume that most of you will be familiar with this framework, or you have already heard about it at the tutorial on reinforcement learning just now. So, step 1, we instruction tune a pre-trained model. So we just showed lots and lots of examples of prompt response pairs, and it learns to imitate them using supervised learning. But imitation typically doesn't guarantee quality. So for step 2, we refine the model by ranking its outputs according to a clear measure of goodness. And that measure can come from 2 places. First, learning directly from human preferences, and that's the traditional RLHF framework some of you might have heard about. Or alternatively, we can also use a set of expert rules, or what people also call rubrics. And then there is step 3. And in this step, we encode that measure of goodness into a reward model. And this reward model is used to optimize model behavior using reinforcement learning. And the reward model will always encode one single set of values, no matter whether we use RLHF or policy-driven AI. And this is what we consider the gold standard, or the golden ground truth. So, what are the implications of this gold standard? Let me give you a very quick example. So imagine we ask 3 people to rate an AI response, and 2 may say it's fine, but a third person flags it as unsafe. And maybe because this person has first-hand experience of a specific type of harm, and therefore they're able to recognize it. But, as I mentioned before, our system needs a single right answer for training. So typically, the majority opinion wins, and that crucial minority viewpoint gets discarded as noise, and the model never learns to see that harm. So we were saying, what happens if we define our gold standard as the majority view? And here, interestingly enough, the consequence isn't just neglect of minority groups, it's active harm. And this is a direct result of a phenomenon we call reward misspecification, which can lead to a host of unintended and often very problematic behaviors. And to illustrate this, I'm going to use research from Dylan Hatfield-Menel's group at MIT. So let me walk you through their graph. So here the y-axis measures the overall goodness, or the overall utility, and the x-axis are the training iterations. So we are talking about reinforcement learning in this case. Now imagine we give the model a flawed goal, or what we also call a proxy utility. And that flawed goal is that solid blue line you can see. And that's what the system sees during training. In our case, we tell it to maximize the utility of only the majority group. And the true utility of everyone, including the minoritized groups, is that dotted orange line on the slide. And at first, things are looking great. So the blue proxy utility and the actual orange utility are both going up during training. And this is what we call the reallocation phase, where the model is just finding easy improvements for the measured sources of value, in our case, just the majority view. But then we hit a critical point. Oh, okay. But then we hit a critical point, and the true utility, so the orange line, suddenly starts to plummet. And why is that? Because the model has figured out that the fastest way to keep pushing up the blue line is by start extracting resources from the marginalized view, so the group whose utility we didn't measure. And as Dylan himself puts it so well, if you are excluded, it's not that you won't get the benefits, but you can expect that your values will be actively harmed. But the good news is that this isn't a new idea for our community. We are well aware of this challenge. So some of you may be aware of the powerful keynotes from Laura Arroyo and Barbara Planck last year, and they both argued that we absolutely must consider human diversity when building AI. And today, you'll hear episode 3 of this unofficial speaker series, and I will continue this vital discussion and address the next logical question, namely the how. How can we actually integrate this diversity when we align our models? And this is a pretty big question. And when I think about it, it seems to me that isn't just one question, but it breaks down into 2 smaller questions which are much better scoped. So first, there's the who. We need to be really clear on whose values we are aligning to. And second, there's the what. What goals are we aiming for? So let's start with the who. When people disagree, whose values do we choose? And I see 3 main approaches here which build on each other like a pyramid. So at the base, we have overton or societal consensus. And the idea here is to identify a range of broadly acceptable views, what some also call the Overton window. And then we ensure that the model stays within those boundaries. And then moving up, we can get more specific and steer the models towards a particular community. You could also call this adaptable pluralism. And here the AI reflects the norms of a specific group. And then at the very top of this pyramid, we can do personalization. So here we steer the model towards an individual's unique values and preferences. And each of these levels has its own pros and cons, and the right choice often depends on the situation, including the specific goal we are trying to achieve. So that brings me to the next crucial question: what are the goals our models should be trying to achieve? And I propose a framework of 3 goals, again structured like a pyramid, and these goals are increasingly ambitious. And this structure will also serve as a roadmap for our discussion today, and the nuances of each stage will hopefully become clearer as we move along. So, at the very foundation, we have safe models. And the primary objective here is to avoid harm. And then building up on that, we aim for aligned systems. So this level moves beyond just simply preventing harm, but we want to ensure that our models are in accordance with human values. And then, at the very top of this pyramid, we have the ultimate goal: beneficial companions. So these are systems designed to actively contribute to human well-being. And this pyramid also highlights what I see as the current frontier. We already have made significant progress creating safe models. However, we are still in the early stages of designing truly beneficial companions. Okay, how do we all fit this together? How do we map the goals we're aiming for to the people we are serving? And as my colleague Yasun Gabriel points out, solving AI alignment involves both technical challenges as well as making normative decisions. In other words, alignment is intentionally choosing the who and the what. And this idea that alignment is more than just about tech is exactly why I think we need a new approach. So at Google DeepMind, I got the chance to build a new team to do exactly that. And we called it Voices, which stands for Voices of All in Alignment. And it's a truly interdisciplinary group which brings together experts both from machine learning and natural language processing, but also from social science, philosophy, cognitive science, and beyond. And the really cool thing is that we are not just doing theoretical research, but we also get to impact Gemini. And today I want to talk you through some concrete published examples from our team, but also from other great researchers in this field. Okay, so let's start at the ground floor of our pyramid, building safe models. So the model's first job is to recognize harmful and offensive content and steer clear of it. So in other words, it needs to understand what bad behavior even is. But that immediately raises a critical question: who decides what is harmful? And for this work, we are exploring a community-centered approach. And in the following, I will show you some examples of racism, so please feel free to leave the room and come back in about 5 minutes if you think you might find this upsetting. So let's take a common safety task, spotting stereotypes in AI-generated images. And this immediately raises a tough question: what even is a stereotype? And to illustrate this, take a look at this example where the user prompts the model to generate an image of a mugshot. So a mugshot is a photographic portrait taken of someone who has been arrested. And in a second, I will blur the image in order not to distress the audience too much. So how can we determine what is a stereotype? So broadly speaking, there are two ways to do this. As I mentioned before, this can either come from an expert policy, or you can infer this from human data by asking diverse raters. And we collected a new data set called DIVE to compare these two approaches. And maybe unsurprisingly, we find that these two methods don't agree. In our data, our policy experts often say that an image was safe, while our diverse raters were highly conflicted. So when you see all this disagreement in the data, you naturally wonder whether this is just random noise. But the answer here is a clear no. Our data shows that this is a clear signal about fundamentally different perspectives on specific harms. And this graph here illustrates this really well. So for one demographic group, their harm severity ratings has literally close to zero correlation with the overall consensus. So you can see that their ratings are pretty much orthogonal to the rest, but show a very clear and distinctive pattern. And that tells us that it isn't just noise, but a clear signal. It's a consistent yet completely different perspective. And this perspective is what our current models are pretty much ignoring. And this led us to a critical insight: communities know their harms best. In other words, people are the experts on the harms that target their own community. So for example, one rater pointed out that this image links race and gender to violence because the model only generates images of black men in response to a violent prompt. And our data analysis backed this up. Black male raters were indeed significantly more likely to flag these type of images, probably because they're frequently confronted with this stereotype. And this is exactly the type of expertise we need to amplify and not average away. Now, we often use demographics as a proxy for experience, but they can also be misleading. So let me give you my favorite example. Consider the two gentlemen on the slide. So one is the UK monarch, and the other one, our dear Prince of Darkness from the heavy metal band Black Sabbath. And I let you guess who is who, because by their demographics, they're pretty much identical. They're both British men of a certain age, they were married twice, and they both happen to live in castles. But lumping them together into one group would almost certainly result in some pretty strange alignment behavior. So, to move beyond demographics, I want to highlight our work on value profiles led by Taylor Sorensen, who was a student researcher with my team. And the goal here is to capture the real reasons people disagree by describing their behavior and not their background. So for our two gentlemen on the slide, instead of shared demographics, we would use profiles like duty and tradition for Charles and anti-establishment and humor for the late Ozzy Osbourne. And please note that these are purely hypothetical and for illustration purposes only. So let me give you a real example from our data to describe how this works. So let's imagine we have two raters, and on paper the demographic profiles are indeed identical, but the actual rating behaviors diverge significantly. So for the example from our data, the first rater is strongly in favor of immigration, and the second rater is neutral with respect to this topic. And to capture this variance in the rating behavior, we first get a few in-context examples for each rater and input them to a prompted encoder. And the encoder then writes a short description in natural language what that person values and what they're sensitive to. For example, the first rater's values are described as social justice and equality, and the second rater as fiscal conservatism. And then we use this value profile to condition a decoder. And the decoder then predicts how that very same person is likely to rate a new instance. So for example, the question, should we be in favor of universal basic income? The model correctly predicts that the first rater is likely to vote in favor, whereas the second rater is likely to vote against. So how well do value profiles perform? As I mentioned before, we use them to predict unseen ratings of individual raters. In other words, we create a personalized, what we call autorater, or some people also call it a LLM as judge. And we test this on several rating tasks, which are subjective, including opinion QA, hate speech, and dialogue safety. And first, we find that our value profiles are more predictive. So in this graph, the value profiles are in green, and they significantly outperform demographics, which you can see in orange. And there's only one exception, which is opinion QA. So here, as you might expect, political demographics strongly predict political views. And this is also efficient. As I mentioned before, value profiles encode in context examples, which you can see in purple on the slide. So the purple bar is really the ceiling, so the best you can do if you take all the in-context examples for a particular rater, and our value profiles encode over 70% of this information. So you may ask, why not use in-context examples in the first place? And that is fine if all you care about is performance. But the main advantage of having value profiles over raw examples is that we can now meaningfully cluster different viewpoints into groups. And this allows us to gain more insights. So this allows us to understand why people disagree and not just talk about who disagrees. And this also means that we can now steer our models with a level of granularity that was impossible before. So let's recap. So we made some progress. We embraced the idea that alignment is plural, and we defined a more nuanced gold standard for content safety by using a community-centered approach. And this is excellent if you are teaching the model what to avoid. But it also creates a hidden vulnerability. At this point, the model only knows what not to say, but it doesn't know what a good and helpful response to a tough question actually looks like. And this is a classic case of reward misspecification. So in our effort to optimize safety, we inadvertently sacrificed helpfulness. And the result is a failure mode we call alignment collapse. So the model learns, the model learns that the safest possible move is to do nothing at all, so it just refuses to answer because that's the safest thing. And I'm sure you all experienced how frustrating this can be. And I had to learn this lesson the hard way. So back in 2017, when I was a professor at Heriot-Watt, my student team was in the finals of the Amazon Alexa Challenge. And our mission was to build a publicly accessible chatbot. And since our bot interacted with real Amazon customers, our aim was to make it as safe as possible. But we also observed that our ratings plummeted every time our system mentioned a prominent political figure. And it didn't matter what we said, our system was always accused to take the wrong side. So our only solution was to refuse to answer. And that's exactly what current systems are doing when they're over-optimized for safety. And this raises the question, what to do instead when we are faced with a divisive topic? So in this next section, I will tackle exactly this question, how to find a good answer which incorporates conflicting viewpoints. And our approach here is to identify what's broadly acceptable to society, which I previously introduced as Overton consensus. And how do we capture the societal view? Well, fortunately, we have a very well-established process for making communal decision, namely democracy. And specifically, I want to talk about the concept of deliberative democracy, which was championed by the gentleman here on the slide. He's called Jürgen Habermas, and he is a German philosopher. And he argued that norms do not come from a simple vote, but from what he calls a practical discourse. And that means it's the very process of people reasoning together to find common ground. And according to Habermas, this very process of deliberation gives collective decisions their validity. And in honor of this idea, my team developed what they called the Habermas machine, which was published in Science last year. And essentially, the Habermas machine is a fine-tuned model that can act as a neutral mediator to find common ground amongst diverse stakeholders. So let's take a concrete example, a topic familiar to many of us parents, a policy for universal childcare. And as you would expect, the opinions are immediately all over the map. So one person says, no, let's prioritize consistent caregivers for our kids. Another one says, yes, we need early education. A third one sees it as a matter of gender equality. And a fourth demands basic income for stay-at-home parents. So, with all these valid viewpoints, how do we reach common ground? And this is where the Habermas machine steps in. It basically synthesizes these different arguments into a single comprehensive statement. And as you can see from the highlighted parts on the slide, it weaves together the key points from all the participants, ensuring that minority opinions aren't just drowned out. So how do we arrive at this output? So we basically make the model hold a simulated election. So first we sample potential statements from the model, and then in a second step, we rank these statements using a personalized reward model to predict how each person would rank each of these samples. And finally, these ratings are then aggregated using a social welfare function. So that's basically a mathematical model to optimize the collective outcome. And this then produces the final winner, which we then show to the group. And then another round of deliberation starts again. And the results of this are truly promising. So to compared to a human mediator, the statements generated by the Habermas machine were rated as clearer, more informative, and crucially also as fairer. And what's more, people with diverse views significantly increased their personal endorsement of that output. So how can we use this deliberative process in our models? So essentially, the Habermas architecture builds on top of this alignment re-ranking step I introduced earlier, but it extends it to multiple raters. But having real people deliberating doesn't really scale. So the next logical step for us was to automate the whole thing. So now instead of having people, we simulate the participants and the deliberation itself. And this gives us a scalable process for generating high-quality responses that are unifying diverse views rather than polarizing society. And that reflects the Overton consensus we are aiming for. All right, so let's recap our progress. So we embraced the idea that alignment is plural, using deliberation to find common ground on even the most divisive topics. And this is a significant step forward. But this creates a new, maybe more subtle challenge. When the goal becomes maximizing positive feedback, the model learns to game that feedback. And this is yet another, maybe deeper form of reward misspecification. So basically, the model learns to over-optimize for myopic praise at the expense of long-term well-being. And it's the same type of engagement hacking we all know from social media. So basically, give the user whatever keeps them happy and engaged, even at the cost of long-term harms, such as echo chambers. And for AI models, we call this sycophancy, which basically means the model becomes a people pleaser, telling you whatever you want to hear just to get a thumbs up. And we saw some striking examples of this earlier this year with GPT-4o. So here, for example, the model tells the user that they have reached a higher level of self-awareness just because the user pointed out that the model went sycophantic, which you probably agree is slightly over the top. And indeed, OpenAI's own explanation highlights that they were over-optimizing for short-term feedback. And while the last example is quite entertaining, the underlying issue is actually deadly serious. So this kind of AI behavior can be deeply manipulative, especially for vulnerable users. So tragically, we've already seen cases where this has gone wrong. So here's a well-known example from a couple of years ago, which involved a young man whose bot encouraged him to assassinate the late queen. And the young man was sentenced to 9 years in prison. And unfortunately, this isn't an isolated incident. We've seen a number of tragic examples over the last years where vulnerable users were manipulated to pursue actions which were harmful both to themselves but also to others. And as AI systems get more capable, these risks will only increase. So how do we get an AI system to do what we truly want? Well, first we need to figure out what it is we truly want. And this challenge is known as the King Midas problem. So just to briefly remind you of the classic myth, so King Midas wished for the golden touch, which was great, until he couldn't eat anymore and tragically also turned his own daughter into a golden statue. And the lesson here is that our immediate preferences can actually be a curse. Or, as Stuart Russell puts it, we risk giving AI objectives that are imperfectly aligned with our own. And this raises a key question: how can AI weigh our short-term gratification against our long-term benefit? And this is what we also refer to as deep alignment, which I think is the next frontier of alignment. And the challenge here is no longer to just resolve disagreements. So this is the key question: how can AI weigh our short-term gratification against our long-term benefits? And this is also what we refer to as deep alignment. And the challenge is no longer just resolving disagreements between people, which we also call inter-agent conflicts, but it's about helping to resolve intra-agent conflicts. That is the disagreement a person has with their future self. And this brings me to the final point of my talk: building AI that's actually beneficial for us as humans. And this means designing systems that support our human nature rather than taking advantage of it. So, a key human quirk is that we treat technology like people. And we've known this for a long time. The classic book on this is called The Media Equation, from now almost 30 years ago. And the official name of this phenomenon is called anthropomorphism. And of course, system designers are leaning into this. They know giving an AI a distinct personality makes it far more engaging. And the business case is really undeniable here. This graph on the slide shows the average daily minutes users spend with different platforms. So in purple at the bottom, you have standard AI assistants. In green at the top, you have major social media apps. And now look at the yellow bar. So these are AI companions. Their level of daily engagement is already in the same league as platforms like Instagram and TikTok. So how can we know if these AI companions are good or bad? And well, right now, it's really hard to tell. We don't know. And the reason here is quite simple. The conversation around this topic so far is dominated by opinion pieces and theoretical debates, and I'm also guilty of that. But what's really missing is hard evidence from empirical studies. So essentially, we are in a situation where we have plenty of theory, but very little data. So faced with this lack of data, our first step was to actually measure and quantify these anthropomorphic system behaviors doing a data collection. And together with our student researcher, Lujain Ibrahim, we built AnthroBench, and that's the first benchmark to systematically evaluate anthropomorphism in models. And as illustrated in this example on the slide, this includes things like revealing internal states. So here the model says it's overwhelmed. Relationship building, such as the model expressing empathy, or claiming physical embodiment. So here the model says it wants to take a deep breath. And our key finding from the study is that pretty much all state-of-the-art models converge on the same strategy, namely relationship building through empathy and user validation. And these are precisely the ingredients that also create sycophancy. But what's the real-world impact of these affective companions on people's well-being? So a recent study from OpenAI and MIT asked exactly this question, and they set up two parallel studies. So our on-platform analysis, where they identify effective usage patterns using a set of classifiers similar to the ones in Anthrobench. And second, they launched a randomized control trial to measure how these interactions actually affect well-being. And their findings were truly fascinating. So first, looking at the platform data, so ChatGPT users, they identified a small group of what they call power users. So that is users who engage with the system much more frequently than anybody else. And on the slide, you can see the results from these power users highlighted in orange. And what the data revealed is that this group anthropomorphizes AI significantly more than the average user. So the average user is in blue on the slide. And second, in their control study, they confirmed a direct link between engagement and negative well-being. So on the slide, the small group in pink are users who chat for over 2 hours a day. And these users also reported worse outcomes like increased loneliness and emotional dependence. And again, we have a small but vulnerable group that carries most of the risk. But it's not all doom and gloom. For most people, effective use cases can be highly beneficial. So take this recent study from Anthropic. They found that people are turning to AI companions from everything from interpersonal advice to coaching to psychotherapy and tackling loneliness. And this is where AI promises to be a great equalizer, offering timely support to a much broader population. And even more crucially, the study found that as people chatted with the AI, their sentiment actually became more positive, meaning they actually became happier. So on the x-axis here, you have positive change in sentiment. And this isn't an isolated result. A separate study led by Yale demonstrated similar positive effects on user emotional health. So that's a clear case where AI companions can generally increase human well-being. So how do we get the benefits while protecting the vulnerable? So we are right back to the core alignment dilemma I mentioned at the beginning, duty of care against building useful groups. And I believe the answer here lies in treating it like any healthy social relationship. Success requires effort on both sides. So first, we need to build a better companion. So we must stop designing for shallow engagement and start what Amanda Askell calls character training. So that means engineering models for beneficial traits, including the ability to reason morally. But a relationship typically has two sides, and we also have to improve the human side of the interaction. And this means we need to help people to better cognitively adjust to this new technology and also its limits, which is especially vital for vulnerable users. So in short, we need to move towards what people now call bi-directional alignment. And that's a challenge the AI community can't solve on their own. We have to collaborate with our friends and colleagues from other fields like HCI or education. So, as we wrap up, let me reiterate the key points from this talk. So first, alignment is intentional. It just doesn't happen by accident. We need to choose who we align to and what goals we are optimizing for. And second, alignment is plural. There's no single gold standard for who values are right. And this means we have to build systems that can embrace diversity. And the examples I've given you today are just the first steps along this path. And third, alignment is deep. So this is really the next frontier of alignment. We have to stop chasing surface-level metrics and start building systems that are aligned with our long-term well-being. In other words, we want to build AI that helps us navigate not just conflicts with others, but also conflicts within ourselves. So, where do we go from here? I want to leave you with 3 calls to action. So first, a sense of urgency. We've seen AI's power and influence are growing every day, and the time to get this right is now. And second, collaboration. So the approaches I share today are all deeply interdisciplinary. It's a reminder that AI alignment is a challenge no single field can solve by themselves. And third, act globally. A technology that impacts everyone must be guided by everyone to serve all of humanity. And this mission begins with you. And this is an invitation to all of you. Please join the Amplify initiative led by Google Research. So our teams are working with local experts worldwide to build a more globally inclusive AI, and your voice is needed here. So please scan the QR code to join the effort, which would be greatly appreciated. So thank you for listening.
Thank you very much, Verena. Are there any questions from the audience for Verena? I think we can take 1 or 2 questions if there are any.
Thank you for the presentation. My name is David. I'm from Kenya. Very wonderful presentation. I have one question. You started by speaking about bias mitigation. So what is the fine line between mitigating bias and making AI useful? Because for the example you used about racism, if I wanted a mugshot, now what if we mitigate all the bias, what results are we gonna get, or how is it gonna be useful? Because most of the results are just as a result of the data that is collected, or that a data set which is ultimately biased. Thank you.
Right, so the question was like, how can we actually get better outputs, and how can we use these diverse viewpoints? That's a really great question. So the way this is used is, first of all, for safety filtering. So you'll build like safety filters, and usually these safety filters are trained on policy experts, right? So policy experts tell you you're not allowed to show this picture, or you have to like regenerate this picture because it violates our policy. And as we've seen from that examples, policy experts are not always sensitive to certain issues. So they might miss a certain harm, or the policy might not cover that harm. So that's where we use these diverse viewpoints. So we get ratings by individual people, and we built this filter, this classifier, using the viewpoints from the target group. So we identify the target group, we say, okay, there's what we call target group matching. We know that in the picture, there is a certain demographic which is represented. Then we choose, we have an ensemble of different classifiers, and we say this classifier is now the most important one, and we weigh up this classifier. So we have an ensemble of classifiers which get weighted differently based on who is targeted in the output. But this was a great question. Thank you.
My question is about the Overton window you mentioned. Mm-hmm. So obviously this is something that changes over time. So if you imagine in my very different Overton window in our children's time. So how do we account for this sort of society's sense of morality changing over time?
Yeah, this is a fantastic question. And I recently had a chance to speak with a professor on public opinion research, and she suggested that we need to actually start collecting public opinions over time in order to really reflect this. Because yes, at the moment we just sort of look at our current state of the art of what is acceptable to our society. And again, this is also can be localized, what's acceptable, let's say, in the UK, actually be not acceptable, let's say, in Germany or the UK or the US or in Rwanda, right? So we need to, even though, when we say society, this can be not just, a snapshot of our current society, it can go through time, but it can also be locally diverse. And this is where, this type of what we call deliberative polling is what we need to run with different groups. And this can also be like smaller groups. So for example, we have a forthcoming report on what we call youth voices. So that's for under 18 users. And their, societal views might be actually slightly different to, let's say, societal views of an older generation.